abstraction. So now let's look at an example of each one of these features. So let's say we have a class with certain members. So if you have a class, how do you access the members of a class? In order to access the members of a class, you need to define a variable for this class. So in order to define a variable, take the class name, followed by the variable name for the class, create an instance of the class by using the new keyword, new class name, right? So now you have created an instance. This is called as creating an instance of a class or instantiating a class. When you create an instance of a class, memory is allocated for the variables that are defined in the class. So this A1 gets a memory on what is called as a stack. When you say new A memory is allocated for these variables on the heap memory, and this A1 would be pointing to this heap memory. Okay? So this particular variable A1, which is of type A, is called as an object or an instance variable of a class. Now using this instance variable, then we access the members of the class. It could be a variable or it could be a method. Likewise. So this is how we access the members of a class. Now apart from the variables and the methods that you define in a class, you also have something called as constructors in a class. Constructors always have a same name as the class name, and they do not have a return type, unlike a method. Why do we need to write the constructor? Now constructors are written generally to initialize the members of the class or do something which is at that particular instance when you need to create an object of a class. Okay? So right now we do not have a constructor in a class. When you don't write a constructor in a class, the compiler will insert what is known as a default constructor. A default constructor is a constructor which does not take any parameter or argument. The compiler will insert a constructor likewise, as if it's almost a do-nothing constructor. So this particular constructor is the default constructor, as there are no arguments being passed here. You can write your own constructors in a class. You can pass parameters to those constructors. For example, we might write a constructor like this. In this case, we have a constructor which takes a int parameter, a single parameter. Now when we write a constructor in a class, then the compiler will no longer insert the default constructor. So for this particular class, we no longer have a default constructor, we just have a parameterized constructor. So in order to create an instance of the class A, now since there is only one constructor available, you need to create an instance by passing the int parameter. Because when does a constructor get executed? The constructor gets executed every time you create an instance, when you say new. So constructors are executed when you create an instance of a class. They are used to initialize the members of a class, and they do not have a return type. If suppose you were to put some return type here, this is no longer a constructor, it's like any other method. Okay? any number of constructors in a class. So now there are two ways of creating an instance of this class. Either by passing an int value while you are creating an instance, or by passing an int comma the character value. So depending on the type of parameters that you are passing, when you create an instance of a class, the appropriate constructor will be called. So let's take a look at the inheritance part of it. So let's assume that we have class B, okay, which wants to inherit from class A. So the keyword is extends A. So class B inherits all the members that are available in class A, plus it can add on its own features, that is attributes and characteristics. So let's assume that we have float f, okay, and here we have void disp with its functionality. If this is class B, you create an instance of class B again. The constructor of class B gets executed. Now what happens out here is, since we have a default constructor in class B, and let's assume that we have not written any constructor in class A as well, which means for both the classes we have a default constructor, right? So when you create an instance of class B, the compiler has already inserted the default constructor, and within that default constructor, the first thing that happens is it invokes the parent constructor. So the execution of the parent constructor gets done first, and then comes back to the child constructor to further execute the instructions that you might have specified in case you have written any constructor. So let's assume that we write a constructor here. So we can write the default constructor. We can also have parameterized constructor out here, just like we did in the parent class. And in the parent class, let's assume we write the default constructor as well. Now let's see what happens. So when we create an instance of this class B by saying new B, it comes into this constructor, but notice that we have not written any call to the parent constructor. Now in this case what happens is, the compiler will insert a call to the parent constructor at the beginning of this constructor, and to make a call to the parent constructor, super call is used. Okay, so the compiler inserts the super call at the beginning of the constructor. We need not write it. So it inserts, if we do not write, the compiler inserts the super call likewise. So when we create an instance of the subclass, the parent constructor gets called, and by default always the compiler inserts the super call for the default constructor. So always the parent default constructor gets called unless and until we specify so. Okay, so therefore the default constructor of the parent gets invoked, and once it finishes executing, the parent constructor comes back to the child constructor to further execute the other instructions specified. Now let's assume that in the parent class, okay, we write a parameterized constructor likewise. In that case, when we create an instance of the subclass, And let's assume there is no super call here, right? We are just writing f is equal to x in our child constructor. Remember, the compiler is going to insert the super call to the parent constructor. The super call that the compiler inserts is super off without any parameter. But now the problem is, in the parent class there is no default constructor since you have written a parameterized constructor. So you end up getting a compiler error. So in such cases, you must always provide explicitly the super call in your child constructor since there is no default constructor in the parent. And the super call has to be specified as the very first instruction in the constructor. So now, since we have in the parent class the constructor which takes an int parameter, you need to make a call to the parent constructor passing some int parameter. If you were to have a default constructor as well in the parent class, apart from your parameterized constructor, then it is not necessary for you to write the super call unless and until you want to explicitly make a call to the parameterized constructor. So if you do not have a default constructor in the parent class, you must always have a super call in the child constructors. If that is your design where in the parent you are not going to specify any default constructor. Otherwise, if you have a default constructor, you can specify the super call to a parameterized constructor or leave it in your child constructor without specifying the super call. Then it will automatically call to the parent constructor, which is a default constructor. So this is how it works between a child and parent class as far as constructors go. So now this particular child class not only has this floatf, the disp function and its constructors, but it has also inherited all the variables and the methods and the constructors from the parent class. So once you create an instance of class B, using the instance of class B, you can access the variable of the child class, the variable of the parent, provided we have the scope. We will talk about scopes later. Let's just assume right now that we can access everything, and their methods. So you can access any member of the parent and the child. Now let's assume that we have int I in the child class as well. Now just before that, let's say in the disp method, if I were to say I is equal to 5, which I are we talking about out here? Previously we did not have this particular I in the child. So the I that we are talking about here comes from the parent class. Or if we were to invoke the set method here, which set method are we talking about? Since we don't have any set method in the child class, we are talking about the set method of the parent, right? So now let's come back to defining int I in the child class. Now the I that we talk about is the I of B and not that of A. Whatever is locally available is the one which it accesses. So if you want to access the I of A right now, you need to use what is known as a super keyword or the super reference. So you say super.I is equal to 5. Now this refers to the I of the parent. When we talk about super, it's the immediate parent. Similarly, methods can also be as specified can also be specified in the child. The same method can also be specified in the parent. Now let's say we also have void set here in the child class. Now when we call set here, it will call the set of the child and not the set of the parent. If you want to again access the set of the parent, you need to say super dot set here, right? Now when you define a method which is same as the method of the parent, it is called as function overriding. So function overriding can occur only between parent and child classes. There should be a parent and child relationship for function overriding to occur. Function overriding is basically redefining a function which has been defined in the parent class. When you override a function in the child, you're redefining the entire functionality of the parent. Now, if I were to take this object and call a set method here, it's going to invoke this set rather than a set method, right? So now what if you have a requirement where although you're calling a set method and it's invoking the set of the child, you'd also want to execute the set of the parent. Then in that case, in the set method of the child, you must call super.set. Now this method call can be written anywhere. It doesn't have to be the first instruction or the last. It can be inserted at any point, right? Now this is between the parent and child classes. Now let's look at what is function overloading, which is nothing but a static binding of polymorphism. So let's move on to polymorphism. You have seen here, we have written more than one constructor for a class. When you write the same method name but with different signatures for the method, it's called as function overloading. So in this particular case, we call this as constructor overloading or overloaded constructors. Similarly, your other functions can also be overloaded. For example, let's say we have a get method. So we can have void get, void get of int, for instance, int get of char, so if I write the same method name with different signature, it's called as function overloading. But take a look at this. We have a get without any parameter which returns void, a get with a int and void, get with a char but the return type is int. So in case of function overloading, you can change the return type provided that the parameters are also different. Okay? But we cannot have a function with the same name, with the same parameter, but just changing in the return type. This is not allowed. Because if you were to create an instance of this class, call the get method, okay, it would not know which get to invoke because there is just a change in the return type. So in case of function or overloading, therefore, it is same function name with different signature. When we talk about different signature, it is the parameters plus the return type can change, or just the parameters by themselves can change, but the return type alone cannot be different in a method. So this is called function overloading. Now for class B, not only do we have all these get methods, if you want, you can define your own get method here as well. So when you create an instance of class B, and for class B you have not only these particular get methods, not only do you have these particular get methods, but you also have a get method which you have defined in class B. So overloading can occur not only within the same class, it can also occur between a parent and child, because for the child you have the methods coming from the parent plus you have the methods of the child itself. So again you have a overloaded get method. But whereas if you look at the set, we had overridden the set method because it's the same signature as the parent. Now let's move on to abstraction and dynamic binding of polymorphism. So we will look at abstraction, data abstraction. So let's assume we have class animal. Do you find any animal as an object existing? No, right? Because we always find something called as dog or fish or cat like this, but you don't say an animal exists, right? But rather it's the type of animal. But all animals have common features or characteristics. So these characteristics, if you were to define in this class animal, you might not be able to define all of them. Maybe partially you can define, maybe you can define certain features, but certain features you might not be able to define at all. So let's look at some of those things. So class animal, let's assume we want to define the intake of animal. What type of a food does animal eat? We cannot really define this because it really depends on the type of animal. So there is no definition for this particular functionality. When you do not know the functionality, that is, you are not aware of it at this particular point, such a definition is called as an abstract definition. So it's called as an abstract data type. So when you need to define a member as abstract data type, you use the keyword abstract. So when you write abstract for a method, there should not be any body specified for the method. When I say body, there should not be a bracket. Again, let's assume that you want to define how an animal makes a sound. We do not know how an animal makes sound, but we do know a particular type of animal, what type of sound it makes. Again, this is an abstract data type. So we define this method as well as abstract. Now let's take breathe. Out here, we do not know how an animal breathes, but we do know something, that is what an animal breathes. So we do have a partial functionality that we can define for this method. So let's say animal breathes oxygen, but how it breathes can be specified later. So, but this particular method is still defined, so it's non-abstract. As long as you have any one member in a class as abstract, the class also has to be defined as abstract. Otherwise, it's a compilation error. So when we have an abstract data type in a class, the class also becomes abstract. And when a class is abstract, which means it is not completely defined, you cannot have any instances existing which is not completely defined. They cannot exist. So therefore, for an abstract class, you cannot define a instance. You cannot say new for a abstract class. But you can have an object variable of an abstract class. We'll talk about this little later. Since we cannot use an abstract class by itself, abstract classes must always be derived. That is, you must have a subclass for an abstract class. So let's say class dog. Class dog extends animal. Similarly, you can have class fish extends animal. So these classes are going to inherit all the members of the parent class. When they inherit, they are inheriting 2 abstract members and 1 non-abstract member. Now if these classes have to be existing, that is, if you should be able to create an instance of these classes must give a definition for the abstract members. If any one abstract member is not defined in a subclass, then that subclass also has to be defined as abstract and further again be subclassed. So let's assume that we should be able to create an instance of these classes. So we're going to define all the abstract members in the class dog. So void intake will be defined. Void sound. You can have functionalities which are very specific to dog also defined out here. Remember, we are expanding by extending from a class. Inheritance is basically used to expand. See, if you just want to use certain members of a class, you're just going to create an instance of the class and access the members. You should not be subclassing it. You should not be extending from a class. Extending a class or inheritance comes into picture only if you want to expand on the existing features. Otherwise, you should avoid inheritance. So let's assume that you have void dog function here, which is specific to the dog class. We need not override the breathe method unless and until we want to. Now let's just leave the breathe method for the dog class. Again, in class fish, you need to implement the intake method and the sound method of the class animal. Plus, this class fish can have its own functionality. You can also, as we mentioned, override the breathe method. Now remember, we said we cannot create an instance of an abstract class. But we did say we can have an object variable which is of type animal, and this object variable animal will hold an instance of the subclass likewise. So you can have a child reference being stored into a parent object variable, whether it's an abstract class or a non-abstract class. This is basically used for dynamic binding. Now we'll come across that little later. Now let's just assume that we create an instance of class dog and put it into a dog variable itself, and fish likewise. And you might want to call, using the dog variable, the sound method. Similarly, using the fish variable, the sound method. Now let's assume that for any class which is of type animal, you're going to invoke all these common functionalities which has been defined in class animal. So instead of keep having to access each of the instance variables and having to call this method like we have written here, you can write a method, let's call it as test, in some class which takes the parameter d and f. Okay, Now this test method, if it has to take a D as a parameter, which is a dog reference, the parameter type has to be dog here, and using that you call the sound, the breathe, etc. Similarly, if you want to be able to pass to the test method the fish reference, you will require to write another test method which takes a fish object as a parameter, call the sound and breathe. So which means if you're going to write thousands of classes derived from animal, you will have thousands of test method doing the same. Now instead of that, let us write a single test method which should be able to access any instance of the class which is of type animal and be able to call the common functionalities of animal. In that case, the parameter type here should be animal. Now let's look at what's happening here. Test method, you're passing the dog reference. Although it's the dog reference that you're passing, it's coming and sitting into a variable which is of type animal. So you're basically storing a child reference into a parent object variable. Okay? Now similarly, again, if you are calling a test method passing a fish reference, again fish is a subclass of animal, so it can be stored into an animal object variable and be able to access. Now when I say a.sound, when I have passed the D as a reference, it is calling the sound method of the dog class, whereas if I am passing the fish reference, it is calling the sound method of the fish class. Now when I call the breathe method, when I have passed the dog reference, since dog class has not redefined, that is overridden the breathe method, it calls the breathe of the parent, whereas for the fish, since we have overridden the breathe, it calls the breathe of the fish class, the overridden method. Now when you pass the child reference into a parent object variable, it is called as upcasting. It is called as upcasting. Now let's look at a little more on this. So right now we just spoke about invoking the common methods that are coming from the parent. What if you have a requirement that using this object variable A, you want to invoke the child method, like for example dog fun. Now if you are calling a test method by passing a dog reference, okay, this animal object variable is holding a dog reference, and you are trying to call dog fun. Although the reference passed is the dog reference, but the object variable type is animal. Using this variable, you can only access those functions which have been declared or defined in the parent class only. Okay? So if at all you need to access the functionality of the child class using the parent object variable, now what you need to do is, first you need to downcast this object variable to a dog type and then access the child method. You can downcast it to a dog type since the dog reference is being passed. But there is a problem in this. The problem is, if you were to call the test method passing a fish reference, here you are trying to cast the fish reference into a dog, but there is no parent-child relationship between dog and fish. So this will end up throwing an error at runtime, and the runtime error that it throws is the class cast exception. So now how do you write this if at all you have this requirement? Now before casting an object variable to a child type, what we need to do is we need to check if the reference that has been passed is of doc type or not. Only if it is of doc type, then downcast it, otherwise move on, right? So how do I check whether a variable is of a particular class type? In order to check that, we have an instance of operator in Java. So if A is instance of dog, then downcast it to a dog and invoke the function. Otherwise, it moves on. So when you take a parent variable and cast it to a child type, it is called as downcasting. When you pass a child reference into a parent variable, it is called as upcasting. This passing variable, instance variable or instance of type child into a parent variable is nothing but your dynamic binding of polymorphism, because once the test method is called with passing the dog reference to animal, at that point whatever functionality you are calling is the functionality on the dog class, so it acts like a dog. But whereas with the fish reference being passed, it calls the functionalities of the fish class. So depending on at runtime what type of reference that you are passing at that point of time, it acts differently. That's why it's called as dynamic binding. Okay, you will find out what this animal A is having a reference of only at runtime. It cannot be found out at compilation time. That's why it's called as dynamic binding. It's polymorphic because each time this animal reference acts differently depending on the type of reference passed. So we have spoken about abstract data types and dynamic binding out here. Let's go back to our class A to cover a little more on constructors and other things. So we had class A with int I, char ch. We had void set, which might be taking an int parameter here. And we had couple of constructors here. Likewise. Now let's look at this here in the set method. We have a variable called I, which is an instance variable. Because how would you access this? You'd create an instance of this class. When you create an instance of this class, a memory is allocated for these variables. Okay? And in order to access this variable, you would just access it with I out here or object.I. Right? You want to specify this instance variable I is going to take the value of the parameter. So you'd actually write it like this, right? I is equal to x. What if this argument variable is also I and your instance variable is also I? In that case, you'd have to say I is equal to I here. Now which I is equated to which I is the question. Now when I say I out here, it always takes the immediate variable I, that is the local variable, the parameterized variable I. So the parameter variable I is being equated to itself. It's not an error here. But what you require here is the parameter variable I value should be equated to an instance variable I. Now, how do I know which instance variable? Which instance variables I that we are talking about? Now, in order to call this set method, you will make use of an object variable of this class and call the set method by passing the parameter. Now, to refer to whatever the object variable I have used in order to invoke the method, if I have to refer to that object variable inside that method, we use the this reference. So you need to say this dot I is equal to I, and the this reference always holds the current or always holds the reference to the current object variable which was used to invoke the method. So in this case, this reference is referring to A1. So when you say this dot I, you are now referring to A1's I variable, whose value is being equated with the local variable I.